Okay, hi. Today for AdMaths, we're going to move on to chapter 4, indices, series, and logarithms, logarithma. And for the first thing we're going to do, we're just going to solve these 9 questions on this piece of paper. So this is all under Hukum Index, the law of indices. So this is all kind of like revision. So let's start with the first question, shall we? Let's simplify. P is the power of negative 1 over 2 times 3p to the power of negative 1 over 3. So I'm going to move it over. I've already copied down the questions. So let's first start to answer them. Okay. P negative 1 over 2, 3p negative 1 over 3. First thing I would approach when answering something like this is trying to, first of all, we know that let's say this is 2 times a as well, times 4. This, for the indexes, it will be equivalent to saying a2 plus 4. That is the relation between them. So we can do that here. So I will write that down. P, sorry, you can't really see it, can you? I'll give you p negative 1 over 2 plus negative 1 over 3. Okay? I'm pretty sure that's how you do it. Hold up. Okay, it is how you do it, but for this p here, this is 1 times 3, you get 3, so you can put the 3 over here. Then you can do this yourself. I'm just gonna sub this into the calculator real quick. So over here you're going to have negative 1 over 2 minus of, or you can do, okay, plus minus what was it, negative 1 over 3. Oh dear. This together you should get negative 5 over 6. So this would be equivalent to 3p power negative 5 over 6. Ta-da! And that is all you have to do to solve this question. So moving on, let's solve something a little bit more quote-unquote complicated. So look at A over here. 3m power negative 2, n power negative 4, and it's all times by power all cube times 1 over 9 meters power 4, sorry, meters, 1 over 9 m power 4, and negative 6 as the index. So I'm just going to write it down here, A. So first we're going to sub the 3 into everything. So 3 power 3, m, negative 2 power 3. This is a times relation. So 3 times 2, that is negative 6. And 4 times 3, that is 12 times 1 over 9 powers negative 6. So negative 6. Then m, 6 times 4, 24. And negative, wait, isn't, oh, sorry. This has no bracket actually. What am I doing? I'm so sorry. This has no bracket, so instead it would just be n negative 6, like that. Okay, we have gone to the first step of trying to simplify the equation. But now, let's trying to make them the same base, right? So, 1 over 9 is essentially 9 negative 1, remember? Because if you want to take this into a positive, you can do this. Ta-da! Just bring it up and you'll get this. So we can write that instead, because power 9 is also under base 3, because if you do 3 times 3, you get 9, which is basically 3 power 2. Alright, so 3, I'm just going to copy this all over again, times 3 power 2. And okay, there was no there was no index up here, so this is assumed to be 1. So we leave it there, m 4, and n negative 6. Okay, now we can simplify this even more. As you can see, this is a times relation, so that means these two will times each other. 3 plus 3 power 2, m negative 6, and it will add 4, and 12 will add negative 6. So you should get something like 3 plus 2, this is 5, m, negative 6 plus 4, that is negative 2, and 12 plus minus 6, so you get a positive 6. Now, over here, you can actually simplify the equation even more, because as you can see, m is a negative. you can turn it into a positive if you like. So what you could do is an additional step. You can actually stop here, but let's say you want to make it a positive. 3, 5 is already positive, and 6 already positive. M, put to the bottom, and then 2. But this is an optional step because usually, unless stated otherwise, this is perfectly acceptable. Next question we have B. So this is a divide relationship. So if times meant that the indices would plus each other, if it was divide, then that would mean they would minus each other out. Okay? So coming back here, a squared b over n b power 8 is times with negative 1 over 2 divided by a3 b negative 9 and then times by 1 over 3. So first, before we do anything, sub those values inside of your equation. It's an equation. It's not really an equation. It's more of an expression because there's no equal sign here. So a squared times, sorry, is it times? Yes, it's times. So 2, you can cancel it out, so you get negative 1, b, 8 times 1 over 2, I'm sorry, I'm not sure what that is. Just gonna put that out here, 8 times, this is negative 1 over 2, so negative 1 over 2, oh dear, you'll get negative 4, okay, cool. Over here, b, negative 4, oh, that's it. Okay, then you divide it by a. Okay, 3 again. This is 1. B. Okay, negative 9. Hold up. We can show evidence that if you take 3 times it by 1 over 3, you should get 1. Ta-da! Now, if we're doing, this is negative 9, so negative 9 times 1 over 3. You get negative 3. B power negative 3. Okay. Now we can obviously minus this off. So a negative 1 will minus off 1. B negative 4 will minus off negative 3. Negative 1. There is no charge. A equals 0. Okay, we're back here. There's actually a mistake I made over here, which is that negative 1, and 0. Salah. Wrong. Okay, so over here, negative 1, obviously, negative 1, if you owe someone 1 ringgit, oh, you can't see my screen. If you owe someone 1 ringgit, then they borrow another 1 ringgit from you, they are not free of charge. No, they still owe you negative 2 ringgit. So, here, absolutely wrong that you're actually supposed to be a negative 2, b negative 4, plus 3 gives you negative 1. Okay, so a negative 2, b negative 1, and that is your final answer. Again, you can stop here, but if you want, you can make it a positive value. So instead, you could put let me think, a negative 2, you could put a and b at the bottom, so a2, b1. You wouldn't have to write b1 actually, but b, and then 1 on top. Optional. Now let's move on to the next question. So these have been simplifying. Now we're going to try to do solving. Fine. 5n equals to 25 over 5 power of 2n. So first find step 1 when you solve we're trying to solve for values. Number 1, try to make them the same base. So by making the same base, it's quite obvious. 25 can be turned into base 5 using 5 power 2. So over here, so I did it. 25 turns into 5 power 2. And then over here, 5 power 2, you minus off 2n. Okay, because you're a divide relationship. This is a divide relationship. Meaning when it comes to indices, it will become substitution. It will become, what do you call it? Minus. So then you do comparison, where you compare the purely just the indices. So n equals to 2 minus 2n, as we wrote here. So just do your simple algebra, throw this over there, you get 3n because negative turns into positive. You get 2, n equals to 2 divided by 3. That is your final answer. Okay, now let's go on to the next question, which I don't know actually where it went. Okay, here we go. Below this we have question B. We have 4 cubed divided by 4 2n is equivalent to 4 power 5. Okay, good thing they're all in the same base. Let me just move this a little bit. They're all in the same base. 4, 4, 4. So this can be 4, 3 minus 2n, and this can be 4, 5. Just compare your values. So you will get 3 minus 2n equals to 5. 3 minus 2n equals to 5. Put the 3 over there, you will get negative 2n is equivalent to 5 minus 3 equals to 2, negative 2n. Okay, 2 and 2, you can divide. 2 divided by 2, you get 1. So, ding, ding. You should get 1 over here, and you should get 1 over here. But this is negative n is equivalent to 1. I want just the positive n. So the negative symbol I throw over there, I get positive. So n equals to negative 1. That is your final answer. Ta-da! Okay, now let's move on. Okay, we've got our next equation. 49x equals to 1 on top, 7 power x minus 2. Okay, first, let's make it the same base, shall we? We know that just from looking at it, 7 times 7 will give you 49. So this 7 times 7 is 7 power 2. So 7, 2 will give you 49. We'll put an x on the outside, but really it's the same thing, 2 times x. Now over here, this is quite confusing to look at. It's a fraction, but don't forget that we did state before that 1 over a, so power, let's say power 2, is equivalent to a negative power 2. Okay? So this is the exact same thing. We can turn it into not a fraction, so back to its negative value. So 7 negative x plus 2. These symbols are flopped over. Alright, now we can just write it out again. 2x is equivalent to 7 negative x plus 2. Now you can start doing your comparison. So compare. It's up to you in the exam if you want to write the word compare or not, but just for explanation wise, I'm going to write it out. Okay, throw the x over to the other side, and that should get you positive. So 3x is equivalent to 2. Now, 3 divide, okay, so take x equals to 2 divided by 3. And that should supposedly be your final answer. Let's see. Yes, it is. Ta-da! Now we can move on to the next question. Come on, we're halfway there. To the next question, it is... Okay, show that. Okay, this is a showing question. Oh, you can't see the book. Okay, it's a showing question in the sense that you're trying to prove something is either true or false. For example, this question here, show that 2x minus 3 is equivalent to 36x minus 216. Okay, first of all, let's just try. What we need to do is we need to take this value and turn it into that. So look at it simply. Let's try and solve this one, shall we? Turn it into the same base. I'm just gonna write here right hand side, then 36x 216 is equivalent to, okay, just from here you can tell 6 power 2. 6 times 6 will give you 36. So 6 2x divide, okay, you can actually put the bracket here. Then, okay, 216. I know that isn't the 6 multiple, I know it is a, what do you call it? A product? Not a product. Is it? It's in the 6 multiplication table, sure. But I don't know exactly. So I'm just gonna take 216 and I'm gonna take 216 and I'm gonna divide it by 6. 36. Hold up. What does that mean? Ooh, okay, cool. 6 power 3. Okay, we found that 6 power 3 will give you the 216. So we're gonna put it there. 6 power 3. And there's no outside things to times with, so we can leave it like this. Okay, then look over here. This can be simplified into 6 2x minus 3. Hey, isn't that the exact same thing? Thus, you can put over here your what do you call this? Your equation is proven. So yes, that should be it. Okay, now let's look at the next question. Okay, again, this is another. Okay, this is a solving question. So come. Ooh, can my book cooperate with me? Thank you. Okay, go down. Given that 4m plus 2 minus of 4m plus 20, 4m minus 1 equals to 4m q. Okay, you almost can't see the question anymore. Find the value of q. Okay, let's go, ladies and gentlemen. First, convert everything to the same base. 20 here, can it be 20 here can turn to 4. Can it? No, it cannot. Okay, no, it cannot. But it is of the same. Before it can divide 20, so this will become 5, and everything here will become 1. So 1, 1, 1. Okay, so now we have 1m plus 2 minus of 1m plus 5, and over here, or should we 1 m minus 1 equals to 1m and then q. It's a times relation, so it's okay, I'll write it like that. Hello. Now let's try to make it a little bit simpler to look at. So 1m plus 2 plus 1m plus 5m negative 1 equivalent to 1m q. Oops, okay. Now what can we do? We can turn it all together. You can take what can you do? Let me think for a moment. Okay, coming back to this question, I think I'm gonna try it again because, to be honest, I don't know what mess I've created. So looking back over here, 4m plus 2 minus of 4m plus 20 times 4m minus 1 equals to 4m cubed. Okay, you can't see the question. There you go. Now, what I think, instead of dividing, right, we can actually take the 4m out of it, because we can kind of factorize everything, because they all share the similarity of 4m. So I'm gonna take 4m outside, and we're gonna be left with whatever is left. So this is 4m times 4, 2, and minus of 1, because this 1 times 4m will give you 4m. And then plus 20, 4m plus 20, 4m is gone, you only have 1, so you only have 4 negative 1, and then is equals to q. You don't have to write 1 out. So then you try and solve this. So 4m, okay, for 16 minus 1, that is 15. Okay, 15 plus 20 times 4 negative 1. 20 times 4 negative 1. 20 times 4 power negative 1 gives you 5. 5, and it's equivalent to q. So 15 plus 15, 20 equals to q, with the 4m on the outside. And let me double check if that is the correct answer. Hey, it is. Hold on, I need to check if it is written like this. Okay, folks, it should be written like this. So 4m. Okay, then finally q is equivalent to 20. Final answer. I'm gonna double check this some other time. I'm kind of tired. Let's go. How many questions left? 1, 2, 3. 3 questions left. Well, let's go. Next page. Okay, the question here is, you've got square root is 64 x minus 4 is equivalent to 1 over 4 power x, 8 power x plus 3. Okay, we're going to solve it. First, let's make this the same base. Everything can be turned into, let me think, is it 2? Because 8 and 4, no, right? 8 and 4 can't really be in the same thing. 2, is there 1 for 64? Let me think. It will be 6. Okay, yes, they can all be turned into 2. So, first or second here, you know the square root? Square root is equivalent to 1 over 2 if I'm not wrong. Let me check your law of indices really quick. It should be like that, yes. Okay. Square root equals to 1 over 2. So, first I'm going to convert this. 2 power 6. And then, x minus 4 is equivalent to, here, 2 power 2 x, and then 2 power 3 x plus 3. Okay, now I'm gonna flip everything. Gonna put all of this on top. I'm gonna put all of this on top just for it to be easier to look at. So 2x, it'll be negative 2x plus 2, negative 3x. Is it negative here? I think so. Negative 3. Then for this one's a bit complicated, so I'm gonna put this in first. 6x minus 4. Then we're gonna put it up of the square root. And I'm kind of confused on what this makes it to be. Give me a moment. Okay, I have to pull out questions I've already done before because I've already forgotten this. See, over here, the a is power 7 and it's outside of a root with root 5. So 5 is at the bottom, 7 is on top. Putting that same method in here, what this should be equivalent to is 6x minus 4 with a nice 2 on top. While this, the other side, we can simplify this on, say, 2, negative 2x. Can we simplify this? Hold on. This is a times relation, as far as I'm concerned. So, plus. Okay, let's compare this before it gets too messy. So, 6x minus 4 equivalent to negative 2x plus negative 3x minus 3. Okay, let's simplify this. You cannot see the equation, god darn. Minus off. These two minus off. You owe someone 2 ringgit, you owe someone 3 ringgit, you still owe them 5x. Just minus off 3. Then, okay, over here nothing much to change. Now, I want to just get x, so I'm going to take this entire thing and I'm going to throw it over to the other side. So, I will get, 2 here. I will get, this is a divide, so over here will be times. So, 6x 4 will times negative 5x minus 3. So, that will give you, 6 times 5 will get you 30, negative 30x squared. Okay, then, darn, okay, think. It's like this. So, negative 3, negative 3 is 6 times 3, that's 18x. Negative, positive 20x. Negative, positive, 4 times, you cannot see anything. 4 times 3, 12. With a 2 at the other side. Then, okay, I'm gonna take all these values to the other side real quick. It's gonna give you 30x squared plus 18x minus 20x is equivalent to 12 minus 2, which is 10. Then whatever is going on here, that is 30x squared minus 2x. Now, what do I do? Good question. I have no clue either. Do I have to factorize this? 30x squared -2, it's a -10. Nope, that's definitely not the way. Gosh, what have I solved wrong? Okay, I do not have the brains as big enough to solve what I've done wrong, so we're just gonna ignore this. Ignore for now. Let's try the other question. Over here we have, okay, if m -4 and 8 times 1/2 times m -1 and 2 is equal to 5, 1, 2, and m is equal to n, find the values of m and 2n. So this is going to be a little bit of substitution. First equation, second equation. Okay, I'm going to first try and make sense of this one first, so times that in m -4. Okay, just, I think I'm going to directly do this, so okay, here. Negative, whoa, that's not negative. What was it? -4 times, honestly, it can just be divided 2 for all I care. Just -2, m -2, and okay, 8 divided by 2, that will give you 4, right? That is 4 times, that's it, okay. Make it simpler, m plus -1 plus 2, 1, 2. Oh, 5, 1, 2, can we, no, I'm gonna leave it there. Can I do anything with 5, 1, 2? 2, can I do anything with it? 2 say to power 9, is that 5, 1, 2? Oh, hey, I cracked it. First try. Continue to 2 power 9. I feel like we're gonna use this. So first of all, -2 plus -1, so that's m -3 and 6 to 9. Now we can use the information given to us. So I'm gonna sub that in. So m is now 2n outside with a -3, and there's an n6 out here with a 2, 9 over here. Okay, I'm gonna move this over to the other page. Okay. I'm going to rewrite the equation. Times relation, this is plus 2, 9, so this is what is this? Let me think. 2 and -3 plus 6, you get a positive 6, positive 3. Now what do we do? Now what do I do? Okay, I've tried to bullshit my way through this, and I have not solved it, because according to whatever disaster I've created here, n is equal to 64, and that is absolutely not the answer. I'm extremely wrong. So you know what, we're just gonna go and show you the book over here. We're just gonna go to the final question, number 9. If we can't solve it, I will leave this for another day. So let's go. 64. Can't even move the book anymore. Okay, over here we have, okay, hold up. Given that E is equivalent to D squared, given that F is equivalent to CD4, given that G is equivalent to 4CD, please give the value, express that in the terms of 64. Express this in terms of C and D. Okay. So we want to get rid of the E's and G's, is what they're saying. So 64 stays there. So this becomes D squared. And F becomes CD4. Okay. Divided by G is now 4CD with the power of 4. Okay, whatever that is. Now, let's see, what can we do here? Okay, for the bottom part over here, we can turn this into four power 4 CD. This is power 4 everything. Everything here is power 4. So the 4 here, this 64, we can turn it to base 4, which would be, how much would that be? Hold up, I don't know. 4. Okay, 3. 4 power 3 d squared cd 4 c 4 d 4. Okay, then I have to think, what are we supposed to do? Pretty sure, oh, whoa, my phone's gonna drop. Pretty sure we can simplify this, so let me just, I think we can do the top here also, like 2 plus 4, that is 6 c divided by 4 c 4 d power 4. Then okay, d6 needs to minus of 4, c1 needs to minus of 4. Let's go. That should give you, I'm gonna ignore this 4 first, d2, that should give you c negative 3. Okay, amazing. Now this, I think I'm gonna put into real numbers. So 4 power 3 divided by 4 power 4. Interesting answer indeed. What is going on? It is equivalent to 1 over 4. That means the charge is, okay. Oh, we need a place to write this. Okay, let me think. 4, 3. That means it's 1 over 4. What else? 1 over 4 d squared c negative 3. Cool. Okay, so this, in simple terms, we can make like these things go up, and for the c negative 3, we can put it to the bottom with 4. So this could be d squared 4 c 3. And that is actually the answer. I am surprised too. Managed to solve it. There you go. We have, okay, so out of 9 questions today, we managed to solve 7 of them. 7 questions done. We have 2 questions that we could not solve, and this will be our quote-unquote homework. That means we will tackle this another day. Thank you so much for witnessing whatever disaster that was, and let's hope I can master this chapter soon enough. Bye bye.